And if I were to look at x plus square root of x minus 2, he has a domain issue. His solution set is not possible all real numbers. He has a domain issue, and this is because of the square root of x, this center term. What do we know about the square root of x? Well, the radicand must be greater than or equal to 0. The radicand is x, must be greater than or equal to 0. So that says x values I come out with had dang well be positive, because it doesn't make sense in the original problem. Because remember, I'm changing variables now, and I'm going to change it into a quadratic equation. The solution to any quadratic is all real numbers. But unfortunately, this guy has a radical in it. So if I take a look and say, okay, now I've got the square root of x, that's my middle term, and if I square the square root of x, what does that become? That becomes just x, right? So that says my substitution is the square root of x, that's my middle term. So my substitution is always based on the middle term when it's in descending powers. And when I square the square root of x, because I'm squaring t, I just get x. So that says wherever I have an x, I put a t squared. Wherever I have a square root of x, I put a t. And there's my equation. And that equation, the domain of that solution set is all real numbers. And then we solve, and it does factor. Yippee for us. It makes life nice. So that t is negative 2, t is positive 1. Well, what do I know t is? Square root of x, right? What do I know about the square root of x and negative 2? Can't be negative, right? And it's not because, it's because that if I think about remember, square root's one of our basic functions. And if I were to graph square root, that's what he looks like. And all y values are positive. Now, I could solve this. The problem is it wouldn't check. Let's get to the easy one then. How do I solve the square root of x is equal to 1? Square both sides, yep. So that x is 1. Now, I know here the square root of x is never negative. So that would eliminate that as a possibility. But just say that we're go willy-nilly and we're not paying attention. And then I go through and square both sides. And I say, well, okay, I've got two answers, x equal 1, x equal 4. That's why anytime you've got a problem that has a domain issue, you want to check your answers. Because this says, suppose x equals 4. Is it true that 4 plus the square root of 4 minus 2 equals 0? Well, this is 4 plus 2 minus 2, which is 4. This is not equal to 0, so this guy doesn't check. So if you were to go through, you could still catch your error if you check your answers. And x equal 1, is it true that 1 plus the square root of 1 minus 2 equals 0? Well, this is 1 plus 1 minus 2 equals 0, and it checks. That's simple.